Okay, this time meron na ba? Wala pa.
Andyan,
Meron
ma'am.
na, ma'am.
Already 16. Pwede na siguro natin start. Okay, so last meeting, na-discuss natin yung compression members. Okay, next topic natin is the column steel base plate. So, sa design and analysis ng column steel base plate, we have to come up with the dimension or the design by solving the required width, the required length, and the corresponding thickness of our steel base plate. So we have here an assembly of our column base plate. We have here the plan view, and we also have here the elevation view. So dito sa elevation view natin, makikita natin yung pedestal. So in between pedestal and our steel column, meron tayong base plate. So nasa pagitan ng column and pedestal yung ating base plate. Okay? So in connecting yung base plate tsaka column natin, ano yung gagamitin natin? To anyone? To connect our steel column and yung base plate natin.
Bolt, ma'am.
How do we connect our column and base plate?
Bolt, ma'am.
Okay. So yung bolt or yung anchor na tawag natin is ginagamit natin to connect yung base plate tsaka yung pedestal. Since yung base plate is steel, yung pedestal is made of concrete. Diba? Kaya bolts or anchor yung ginagamit to connect this base plate and pedestal. Dito naman sa ating column tsaka base plate, since both are made up of steel, ang ginagamit natin dyan is welds. Mini-welding natin yung dalawa. Okay? So, in our plan view, ito yung ating pedestal. Ito naman yung ating base plate and ito yung ating steel column. So yan yung plan view natin. So the base plate is used to distribute load that make the concentrated load uniform from the column to our pedestal or yung concrete coating natin. This is to widen the area para i-distribute niya yung ating load mula sa column papunta dito sa ating pedestal. Since without the base plate, the contact area nung column tsaka pedestal is direct siya. And direct contact ng column, yung loads from column to the pedestal is critical to bearing. So gumagamit tayo ng pedestal to widen up and distribute the load from the column papunta doon sa ating pedestal. Okay? So yung mga bagong pasok pa lang, kindly go to our chat box. Then write your last name para ma-record yung attendance ninyo and the time you enter our Google Meet. Okay? So in designing base plate, in designing base plate, we must meet the limitations set by our NSTP. So yung NSTP specification natin, meron tayong limit in designing base plate that is best based on our bearing pressure on support, and yung isa is based on bending stress on our base plate. So meron tayong equation. So yung una, yung based on bearing pressure on support. Okay, so we have here two equations to solve for our nominal strength. So ito yung kukunin natin. So yung if our bearing covers the full area of our concrete support, ito yung gagamitin nating nominal strength na equation, that is 0.85 FC prime A1. This is in MPa. Okay? And pag yung bearing naman natin covers less than the full area of the concrete support, yung PP natin is this equation. So we have 0.85 FC prime area 1 multiplied by the area 2, the square root of area 2 over area 1. And this equation, yung itong equation dapat natin should not exceed 1.7 SC prime of area 1. Okay? So in cases na mag-exceed ito yung gagamitin nating value. Okay? So dapat hindi mag-exceed yung nakuha nating value dito sa equation with this equation. So pag nag-exceed siya, ang kukunin natin itong equation. Okay? That is based on bearing that covering less than the full area of concrete. So meron tayong notations dito. Yung PP natin, yung bearing stress, yung nominal strength, yung nominal strength pa lang ito sa bearing stress, and yung sa pressure. Okay? And then yung FT prime natin is the 28 compressive strength of concrete. This is in MPa. So yung area 1, we have the area of steel. Concentrically bearing on concrete support. And then yung area 2 natin is the maximum area of the portion of the supporting surface. So i-discuss natin mamaya itong area, paano pagkuha ng area 1 and paano pagkuha ng area 2. And the general provision, the NSCP general provision is that our design strength is greater or less than our ultimate, or equal to, greater or equal to our ultimate load. And for LRFT, ito yung gagamitin nating factor. And for ASD, we have 2.31 as our factor. The same pa rin sa previous, yung sa tension and compression natin, that our design or our allowable strength should be greater or equal to our ultimate load or our service loads. Okay? So, yung FT prime, compressive strength yan ng concrete. Okay, punta tayo paano pagkuha ng area 1, yung area of steel concentric bearing ng concrete, tapos yung area 2 natin. So to determine the values of area 1 and area 2, we have here a sample. So pag ito yung pedestal natin, we have a square pedestal, we have a square base plate. So pag square ang pedestal mo, square din ang base plate mo, yung area 1 natin is yung area in contact between the pedestal and base plate. Yung ating area still concentrically bearing. So yung in contact between pedestal and base plate. So yung in contact na area is yung area ng base plate, di ba? Yan yung maximum na in contact between the base plate and then the pedestal. So yung area mo magiging 150 by 150. And then, yung area 2 naman natin, that is the maximum area of the portion of the supporting surface that is geometrically similar. Okay. So, geometrically similar. Since this is square, yung area 2 natin is 300 by 300. Parehas yung centroid of area ng dalawa, yung base plate tsaka yung pedestal. So, pag square, ang ating both yung pedestal natin tsaka yung base plate natin, yung area 1 natin is yung area ng base plate kasi yan yung in contact with the pedestal. And then yung area 2 natin is the maximum yung area ng pedestal. Okay? So, what if we have rectangular pedestal tapos square naman yung base plate natin? So area 1, parehas, yung in contact between the base plate and pedestal, yun yung ating area ng pedestal. Kasi ito yung in contact with the area ng base plate, hindi pedestal. Area ng base plate, ito yun. Kasi yan yung in contact with the pedestal. Yan yung ating area 1. And for our area 2, we have to get the maximum area na geometric similar. Okay? So, for area 2 naman, since this is a rectangular, so hindi natin pwedeng kunin yung buong area ng pedestal. Kasi pag kinuha natin yung area ng buong pedestal, that is not geometrically similar with this area of our base plate. Okay? So, yung unang gagawin natin is we have to maximize either yung length or yung width ng ating pedestal. Okay? So, in this example, ang min-maximize ko is yung width in the area. We have to maximize yung width. So, yung dito sa example, ang min-maximize ko is yung width ng ating pedestal, which is through 300. Okay? And then, pag min-maximize ko yung 300, pwede ko ding i-maximize na 300 yung aking length kasi pasok pa rin siya dito sa ating dimension na 600. Okay? So, pwede siyang ma-maximize and then yung centroid ng both yung pedestal sa base plate parehas, yung centroid nila. So, geometrically, similar sila. So, yung area po natin dito is 300 by 300. Ito kasi 600 ang min-maximize ko. Pag 600 ang min-maximize ko, hindi siya pasok dito sa ating width ng ating pedestal. Hanggang 300 lang tayo. Okay? So, maximize ko lang yung area 2. So, yung area 2 natin is 300 by 300. Yung area 1 natin is yung in contact, that is 250 by 250. Okay? So, what if naman yung ating pedestal and base plate is in rectangular shape? So, yung pedestal natin, rectangular. Yung base plate natin, rectangular din. Okay, paano natin kukunin yung area 1 and area 2? Okay? So, yung area 1 natin, in contact pa rin. So, yung area pa rin ng ating base plate. So, tingin kayo dito sa left drawing. So, yung area 1 natin is yung in contact. So, ito pa rin yung area 1 natin. Kasi yan yung in contact between base plate and yung pedestal. So, that is 300 by 550. Paano yung area 2 natin? So, area 2. So, pag min-maximize natin yung 300, this is rectangular kasi rectangular din yung ating base plate. Pag min-maximize natin yung 300 and ratio and proportion tayo, that is para makuha yung length natin. So, pag nag-ratio and proportion tayo, kasi pag min-maximize natin yung 300, hindi pa natin alam yung length nito, yung length na kukunin natin sa pedestal. Okay? So, dininote ko yan as D. And then, by ratio and proportion, that is D over 450, ito yan, is equal to 550 over 300. So, pag sinolve yan, ang value ng Z natin is equal to 825. Okay? So yung Z natin is 825. So pag tinitingnan natin yung dimension ng pedestal natin, ang dimension lang natin is hanggang 700. Okay? So yung Z na nakuha natin, which is 825, is not possible. Because this is greater than 700, which is our maximum dimension for pedestal. So, hindi pwede na yung area mo is 450 by 825. Mali yun. So pag hindi siya pasok dito, i-revise mo yung kukunin mo full width or full length. So pag ni-revise mo, yung kukunin mo full dimension, so pag ang kinuha mong full dimension is yung width, hindi siya pasok. So i-revise mo siya, ang kukunin mong width, maximum is yung length. Okay? So pag yung kinuha mong maximum is yung length, that is 700. Yung equivalent nitong dimension ng base plate dito sa pedestal, ayan, nag-denote din ako ng D. Kasi yan yung geometrically similar dito sa ating base plate. Hindi pa natin alam yung dimension. Okay? So, nag-denote ako ng Z. And by ratio and proportion, makukuha din natin yung value ng Z. Since sabi nga natin, geometrically similar with this concentric area, which is the area of the base plate. So, pag nag-ratio and proportion ako, we have Z o Z over 700 is equal to 300 by 550. So, yung makukuha mong value ng Z is 381.8. which is less than 450 na maximum dimension ng ating width ng pedestal. So, pasok siya. So, ngayon, pag pasok na siya, ang kukunin yung maximum area na geometrical similar to and concentric with the load area, yung itong area ng base plate natin, is equal to 382 by 700. Okay, so yan yung magiging area 2 natin. So yung C and then yung 700. Okay? So, so far, do you have any questions?
Wala naman, ma'am.
Okay, so we move on to the next, yung limit natin that is based on our bending strength. So yung una, that is based on the bearing pressure on support. This time, this is based on the bending stress on the base plate. So we have here drawing or diagram of our base plate with the pedestal tapos with the column. So, consider yung bending stress on the base plate kasi nagbe-bend, meron tayong bending dito sa both width ng N, nagbe-bend tayo dyan, and meron din tayong bending dito sa M. Yan. Itong dimension ng M and N. Okay? So, for the provision, parehas pa rin that our nominal moment, yung nominal strength moment natin is greater than or equal to yung ultimate for the LRFD and for the ASD, that is allowable moment. So ito, kinonsider ko lang yung LRFD. So pwede din yung ASD that yung tawag dito, yung factor niya is equal to 1.67. Okay? So ito, kinonsider ko lang yung LRFD. And siya nga pala, pag wala akong nabanggit during your activities, quiz, or even exam, lahat, pag wala akong sinabi kung anong gagamitin ninyo na procedure, always use LRFD. Okay? So pag isa lang yung hinahanap po, always use LRFD. Pag wala akong nabanggit na design or the allowable, yung binanggit ko lang is just have to find the nominal strength, mga ganon. Always use LRFD. Okay? So sa economic tayo. Sa economical procedure tayo. So always use LRFD. Kaintindihan tayo doon ha? Okay. So the nominal moment MP, the nominal moment MP and MN is equal to the Fy multiplied by Z. So yung plastic modulus natin. Okay? So yung equation actually natin ng T, kasi yung based on the bearing pressure on support, ang makukuha natin doon is the length and the width of our base plate. Ang makukuha natin dito based on the bending stress on base plate is yung thickness ng ating base plate pag nag-design tayo. Okay? So yung itong equation, yung equation na ito, actually nakuha dito yan. Okay? So pag kumuha ka ng strip, tapos nag-moment ka dito sa critical section for moment, okay? So yung stress natin is equal to MC over I. Yung I ng rectangular is equal to 1 over 12 BH cube. I hope you still remember your lower design subject. Okay? And yung C natin is 1/2 of D, di ba? And then yung M natin, kaya ito yung lumabas na equation natin dyan. Okay? So, sa pagkuha ng thickness equation nung previous slide, okay, so we have here the stress sa pressure yan yung FP, yung bearing natin. For the base plate, yung column base plate. Always remember that stress is equal to load over area. So yung load natin, PU, yung area natin is N. So always remember, stress is equal to load over area. Okay? So pag nag-moment ako dito, para makuha natin, kasi yung MP, meron na tayong equation dyan sa MP, di ba? That is Fy over multiplied by D, yung plastic modulus natin. So para makuha yung MU, mag-moment tayo dito sa ating critical section, sa kinuha nating strip. So pag nag-moment tayo dyan, yan. So FP times X over 2. Nag-moment tayo dito. Okay? And then substituting yung equation ng FP, yung ito, PU over BN, makukuha natin itong equation. So yan yung equation natin for the MU. Ito yung equation natin. So meron na tayong equation ng MU, meron din tayong equation ng MP. Okay? That is Fy times Z. Okay? So this time, yung Z natin, yung plastic modulus natin, is yung statically moment above, yung ating strip, area above, and then yung area below. So if we have here our strip, ito yung neutral axis natin. Yung Z is the plastic modulus that is statical moment of area above plus yung static moment area below. So ito yung above, ito yung below. Okay? So if we have here our neutral axis, yung ating area 1 is yung area natin dito sa taas. That is our area 1. And then yung area 2 natin is yung sa baba, yung A2 natin. And yung Y1 natin, that is the centroid area of the area above, yung centroid area ng area natin dito sa taas, measured from the neutral axis. So pag ito yung centroid dito sa taas, papuntang neutral axis, meron tayong dimension dyan. Okay? And then yung y2 naman natin, baliktad naman, centroid area of the area below measured from the neutral axis. So pag ito yung neutral axis natin, ito yung dimension natin. Okay? So pag kumuha tayo ng strip that is equal to t, pag thickness yan, yung half niya is t over 2. Diba? Kasi yan yung half. So yung area 1 natin is equal to pag kumuha tayo ng strip. So, yung area 1 natin is equal to 1 times t over 2. Diba? Multiplied by y1. So, ano yung y1 natin in terms of t? So, if this is t over 2, yung centroid niya, yung distance niya sa centroid niya, that will be t over 4. Diba? Tama ba ako? T over 4? Tama. Kasi t over 2 yan, yung half pa ng t over 2, that is 1/4. So multiply by t over 4. So that is the statical moment above, yung A1, Y1. Plus, yung statical moment area below, that is A2, Y2, parehas lang sila, di ba? Parehas lang. So plus 1 over t over 2, t over 4 pa rin. Kaya pag sinimplify nyo yan, ang lalabas itong equation. That is t is equal to t squared over 4. In terms of t na yung c natin. So meron na tayong equations for c, meron na tayong equations for mu. Pag sinubstitute natin dyan, dito, sa NSTP provision natin, yan, sinubstitute natin yung values. Ito yung makukuha nating equation. Okay? That is in LRFD kasi 0.9 yung ginamit natin. So pag AFD, that is over factor na omega. Okay? So kaya natin nakuha itong equation for thickness that is, that should be greater or equal to x square root of 2 pu over 0.9 bn fy. So, ganyan yung pagkuha ng equation ng t natin. And then, yung x natin dito is the larger value ng m and n. So, you need to solve both the value of m and value of n. Then, kung ano yung mas malaki, yun yung x natin dito sa equation. Okay? So, ito yung magiging equation natin for n. Paano natin kukunin yung n dito sa looking at our figure here? Paano natin kukunin yung n? Diba? Pag minus ka lang dyan. O, diba? Yung b nung ating base plate minus 0.8 times b. Yung b na ito, small b, is the dimension ng ating column. And yung b, yan yung depth ng ating column, yung section column natin. Okay? So, minus 0.8 multiply by b over 2. Kasi dalawa. Merong isa dito, merong isa dito. Yan. Pagkuha ng value ng n. And yung small letter m naman, sa pagkuha niyan, n minus, kasi ito yung n natin, n minus 0.9 of d over 2 kasi dalawa yung m natin. Okay? So, yan yung pagkuha ng m and value ng n natin. So, pag sinubstitute nyo lahat yan, makukuha natin yung thickness. So, dapat alam nyo din mag-manipulate yung ating equation if, for example, yung given is yung t. Diba? Hindi yun yung kinukuha nyo. So, dapat alam nyo mag-manipulate ng given equation. Okay? Okay, so we have here a problem. Before we proceed to our problem, are there any questions before we proceed sa ating problem solving? Wala? Okay. So, proceeding dito sa ating problem 1. So, we have here a 30 loaf we have 400, 700 is loaded to a column having these properties. Yung BF natin is 200, yung D natin is 300. As shown in this video, so we have here video. Assuming that the base plate rests on the whole area. Okay, sabi niya, rest on the whole area. So, dito pa lang, alam na natin kung anong gagamitin nating equation na nominal strength na P. Okay? And then we also have here given FC prime that is equal to 21. And then yung Fy natin is equal to 248. We have to design a square. Sabi niya, square base plate to support the column. So pag sinabing square, yung B natin is equal to N. Okay? And then of course, we also have to solve for the thickness. Okay? So we have here the required and the given. Okay. So ano yung unang kukunin natin for our solution, for us to solve for our dimension ating square base plate? So pag full area, di ba, yung past slide natin, our equation for our nominal strength is equal to 0.85 FC prime A1. Diba? Yan yung ating equation. So ano yung unang kukunin natin? Anong unang kukunin natin? So of course, yung nominal strength natin, i-compare natin siya sa ultimate or the service load. So yung unang-unang gagawin natin is to solve for our value of ultimate load. That is equal to 1.2 dead load plus 1.6 live. So what would be our ultimate load? Finally solve. That is equal to Miss Laksa. Ano yung ultimate load natin? Anong value natin dito? $1.2 dead load plus 1.6 live load.
600, ma'am.
Ilan? 1,000?
1,600, ma'am.
Okay, 1,600 kilo Newton. Okay. So we have here the value of PP. Diba? Ang sabi ng code natin, our nominal, our design or our allowable strength, that is for LRFD. So wala tayong binanggit. So we will be using the LRFD method. Okay. So yung design natin, that is the factor multiplied by PP should be equal or greater than or equal to our PU. Diba? Okay, we have now the value of PU. Meron tayong factor and meron tayong equation ng PP. Okay? So to solve for the dimension of square, ang unang-unang kukunin natin is yung area natin. Diba? So, dimension width times length is equal to area. Kaya kailangan natin kunin yung area. So, substituting here in our limits, yung C natin is 0.65. And yung PP natin, that is, that is 0.85. FC prime, anong FC prime natin? That is 21 MPa. So Newton mm squared 21 multiplied by our area 1. This should be greater or equal to U. Okay. So, meron na tayong PU, that is 1,600. Naka-kilonewton ito. Yung 21 natin, naka-newton mm. Naka-newton mm square tayo dito. Okay? So, dapat i-convert mo niya yung 1,600 kilonewton into newton before substituting values. So, ano yung value ng area 1 natin dito? So, ano yung value ng area 1 natin dito? So, kindly solve this. So, yung area 1 natin should be greater or equal to. So, yung makukuha natin dito is in mm squared. So, yung PU natin dito is 1,600 times 1,000 in Newton. So, what would be our area 1? So, anyone? O Miss Del Rosario? Miss Del Rosario? Absent ba ito? Wala pa siya? So, yeah. Ano? 1? Ano yung value natin dito, Miss Del Rosario? That is... or anyone? That is 0.65 times 0.85. 21, that is... So, ilan ito? That is equal to 1,37901.31. So, kindly check if my calculation is correct. Is this correct? Dapat nakahanda na din yung calculator ninyo pag nag-Google Meet tayo. So, assuming yung na-compute kong area 1 is correct. Meron na tayong area. Sabi natin yung area 1, that is the steel concentrically bearing on the concrete support. So, that will be our area for our steel base plate. So, this is the area of our base plate. Okay? And pag meron na tayong area, square base plate tayo, so B is equal to N. Okay? So yung area natin is equal to B times N. And yung B is equal to N natin. So yung area natin, which is 137,901.31 mm squared, is equal to, let's say, B is equal to N. So, B squared. So, ano yung B natin? That is the square root of this value that is equal to 371.35 in mm. So, kindly check.
Correct, ma'am.
Okay. So, ito yung base natin. Square tayo. So, yung N din natin is equal to this value. So, yan yung magiging dimension natin for our base plate. So, in action, so gawin ninyo siyang full number sa actual. Kasi mahirap mag-measure ng ganyan. Walang paatang available na may point something. Di ba? However, dito sa klase natin, kunin pa rin ninyo yung exact value na na-compute natin. Okay? So, kunin pa rin natin yung exact value na na-compute natin. But in actual, say yung B natin or yung A natin, say that is 375 mm by 375 mm. Mga ganun. Dapat sa actual. Kasi walang point-point, may hihirapan tayo dyan. Pero sabi ko nga, dito, activities natin, exam, quiz, kunin natin yung exact na na-compute natin na B and N. Okay? So we have now our dimensions. Meron na tayong base, meron na tayong width, and meron na tayong length. Ang kulang na lang natin is yung thickness. Okay? Kulang na lang natin is yung thickness. So to solve for thickness, kunin natin yung equation based on the bending stress on our base plate. Okay? So, yung P natin kanina is equal to 1,600 Newton. So, for solving for our thickness, yung thickness natin should be greater or equal to, that is X, the square root of 2PU over 0.9 of BNXY. So, yan yung equation natin. Okay? So, we have value of PU, that is 1,600. Meron na din tayong value ng B, meron na din tayong N, meron na tayong FY. Ang wala lang yung X. So, sabi natin kanina, X is the larger value between N and M. Okay? So, we need to solve the values of M, yung M, and yung value ng N. Okay? So, let's start by solving M. So, yung M natin, that is equal to, ano yung M natin? That is N minus 0.95 of D over 2. Kasi dalawa nga sa magkabilaan. Okay? So, yung N natin, ilan yung na-compute natin kanina? That is 371.35. Yan yung na-compute natin kanina. Minus 0.95. Ano yung D natin? That is 300. So, yung D natin is yung depth ng ating column. So, ito yan. Over 2. So, ano yung value natin for M?
43.175, ma'am.
Okay, that is 43.175 mm. And then for N. So, kindly solve for value of N, that is B, or this is N pa rin kasi that is square, or this is equal to B. So, pag rectangle yan, that is equal to B. So, B minus 0.8 of B over 2. Substituting yung values natin. So, kindly solve this. Yung B for column is 200. Okay. So, ano yung magiging value ng N natin? What would be our value for N that is equal to
105.675.
So that is 105.675 F. Okay? And then MN. O ano na yung magiging X natin? This is MN. Ano yung value ng X natin? So the larger value between M and N, that is equal to 105.675. So yan yung N natin. Okay? So in our equation, masusolve na natin yung T. Kasi meron na tayong X, meron na tayong P, meron na tayong D, meron na tayong N, and meron na tayong XY. So we just have to substitute value dito sa ating T. Okay? That is, so pag-solve ito, that is 105.675 with square root of in mm tayo. 2 PU, that is 1,600 times 1,000. Newton ito over 0.9. That is 371.35. That is in mm squared over 240. Okay? So magkakansel yung Newton, magkakansel yung mm dito. So ang nakitira na lang is F. Ano yung value natin dito sa P? Ano yung thickness natin? That is equal to
34.07.
24, is this correct?
Yes, ma'am. 34.07.
0.07.
34.07 and 10. Okay. So, yung magiging sagot natin, meron na tayo T, meron na tayo B, and meron na tayo T. So, the dimension of our basic plate is equal to 371.35 by 371.35 by 34.07 in and in and. Okay. So yan yung magiging sagot natin for number 1. So in that file, i-round off nito sa code number. Okay. So yan na yung sagot natin for number problem number 1. Okay? So is there any other question before we proceed for problem number 2? Okay. So for problem number 2, so kindly read Miss Sample. Ito. Is almorphic. Mga tinatawag kung hindi sumasagot in absent po kayo. Kaya lang basahin actually, pero kung absent kayo at nakikinig, hindi lang din pumasok, iniwan, wala na. Miss Almorphic. Dito.
Ma'am Ada.
Miss Marvel.
Ma'am.
Kindly read.
The base plate rests on a 7 mm by 700 mm concrete column as shown. Using FC equals to 27 MPa, determine the design bearing strength of the 40 mm thick A36 steel. Fy is equals to 248 MPa base plate. The plate does not cover the full area.
Okay, so we have here the diagram for our problem number 2. So, the dimension ng ating pedestal kung saan yung base plate natin nakapatong is 700 by 700. Okay, so meron din tayong B and B for our column, that is 2.8 and 864. And yung ating dimension ng base plate is equal to 640 by 500. So, ano yung pinukuha natin dito? We're going to solve for the design bearing strength. So, yung design bearing strength natin that is equal to the LRFP pa rin tayo. Ayan, yan yung ating design bearing strength. So, dapat yung design bearing strength natin, is okay doon sa voltage natin. That is yung ating sa support and then yung sa ating bending. So, dapat yung ating design bearing strength is greater than or equal to the ultimate load na nakuha natin doon sa based on bearing pressure on support and then based on the bending stress on our base plate. So, kailangan greater than sa both. Hindi pwedeng yung isa lang. Okay? Kasi mag-debate pa rin siya. So, dapat ako, so, i-compare natin, tapos yung smaller, yun yung kukunin natin EU natin. Okay? So, for our solution, so based on the bearing pressure on our support, so sabi natin, yung ating plate does not cover yung full area. So yung equation natin for PT is equal to 0.85 FC prime area 1 is square root of A2 A1. And this should be less than or equal to our 1.70 FC prime A1. Okay? So, meron na tayong FT prime. Kunin natin yung values ng ating area 1 and area 2. So, looking at this figure, ito na yung figure natin. Yung area 1 natin, that is equal to the dimension ng ating base plate, that is 500 by 640. Diba? So, can we solve for our area 1, that is 500 by 640, ang value natin dito. Okay, so that is 320,000 mm. Okay, so for area 2, ano yung magiging area natin? So that is the largest maximum area that is geometrically concentric or similar. Ano yung magiging area to natin? O ito, sorry po na actually. So yung kinuha natin dito is yung buong length, 700. So pag tinawag natin yan, 700. Or C, 700 is to C or C over 700 is equal to, that is 500 over 640. Ano yung magiging value natin ng C dito? So we have 700 times 500 over 640. Anong value natin ng C dito?
58,333.33 mm squared, ma'am.
Ilan?
58,333.33, ma'am.
Are you sure?
Ma'am, 546.875.
546.875.
Okay. Kasi 8,000, we only have 700. So that is equal to ilan yun?
546.875.
546.875.
875. 875, ma'am.
So, pag nakuha na natin yung C, meron na tayong area that is P multiplied by our uh, 10, which is 700. So, magiging area po natin is equal to 546.88 multiplied by 700. So, ano yung magiging area po natin? That will be equal to 3, 8, 2, 8, 1, 8, and squared. So, can you check? Tama. Okay. So, meron na tayong values. We have to substitute now our values in our equation. Tipsy natin. Substituting yung values natin, that is 0.85. Ang FA prime natin is equal to 27. Ang ating area 1, that is 320,000 mm squared. So, huwag nyo malimutan yung mga unit natin, at hindi kayo malito kung ano yung final unit nito. The square root of area 2 and area 1. So, ilan ito? So, this is Newton, mm squared, this is mm squared. So, magkakancel yan. Mm, this is mm squared, magkakancel yan. So, ang matitirang unit natin is Newton. So, ano yung values natin dito? Yung PP.
Ay 254,011.
So, we have 8. Paki-check na kung tama yung calculation ko. 536.72 Newton.
Yes, ma'am, correct.
Yes, ma'am.
Okay. And this should be less than or equal to this equation. Kasi meron tayong limit, yung 1.7 ST prime A1. So, pakikuha yung value ng 1.7 ST prime A1. So, dapat gawin ito mas maliit or equal to the value of 1.70 ST prime A1. So, that is equal to 1,4,688,000 Newton. Check. So, that is 1,414 million. Ito, 8 million. Okay, so pasok siya. That is less than our 14,688,000. So, ito yung kukunin natin P. Okay? Ito yung kukunin natin. PP. Okay, so yung design natin, yung design strength natin dito, yung design strength natin dito is PPP. You just have to substitute values. Okay? So, ano yung PPP natin? That is 0.65 multiplied by yung value ng PP natin. So, ilan yung makukuha natin dito? 0.65 multiplied by i-convert nyo na nga sa kilonewton.
5221.15, ma'am.
5,221.15 kilos. So, yan yung design strength natin based on the bearing pressure. Or, yeah. Yan yung design strength natin based on the bearing pressure. So, pag dinagdagan ko yung question that what is the load, the ultimate load. So, alam naman natin na PP is greater than or equal to PU. So, pag PP natin yan, ang PU natin is equal to this value. Pag dinagdagan ko lang yung plus 1 na ultimate load. So, makukuha niyo din yung ultimate load gamit ito dito sa question. But I think yung question natin is, yung hinahanap natin is the design bearing strength. So we have this value. That is based on the bearing pressure on support. So, i-check din natin yung based on our bending. So, based on bending stress on base plate, we have the equation that is E, that is greater than X, 2PU 0.9 B and Fy. So, yan yung equation natin. And from our problem, given yung thickness natin, that is 40 mm. Okay? So, meron tayong thickness. The value of PU is still unknown. Yung ating BNN given, and then Fy given. So yung X, that is the larger value between M and N. Okay? So yung design natin is greater than or equal to PU. Okay? So ang PU natin dito is equal to PP. PU is equal to PP. And then yung PP natin, okay. So ito. Yung PU natin is equal to this. So ito yung hinahanap natin, the design. Diba? So let's say that is, let's denote that as, ganyan pa rin. Donate natin, ganyan pa rin siya. Okay? So substituting yung values, makukuha natin yung values na ito. That is equal to yung U natin. Okay? So isolve muna natin yung value ng X. So M, that is N minus 0.9 B, 95 of B over 2. So kindly solve the value here. We have N is 640. 640 minus 0.95, yung D natin is 36 over. And yung N natin is equal to B minus 0.80 B over 2. That is equal to 500 minus 0.8. Yung B, 258 over 2. So, ano yung value ng M natin?
147.1, ma'am.
So 147.1 mm. And yung N natin?
$146.8,
146.8 mm. Okay? So alam mo na ngayon yung magiging X natin. That is the larger between M and N. That is equal to 147. Okay? So pag sinubstitute natin lahat yung values natin dito sa ating equation, makukuha natin yung value ng ating PU. Di ba? So substituting lahat ng values, so pag-solve din yung pag sinubstitute natin. That is 640 by 500 times 2. And Newton. So ano yung magiging value natin for our PU?
Two six 0.64.
2640.64. That is in kilo Newton. Feeling ko pinag-convert na niya na yung kilo Newton. So, yung ating CPP, sabi natin, is greater than or equal to PU. So, ang nasolve natin is the PU, di ba? Yung PPP natin is equal to this value. Kasi greater than or equal to, sabi niya, PU. So, ito yung design strength natin based on the bending stress on base plate. So we have here the design based on the bending stress and based on the PP. Ito naman yung magiging trend natin. So ano na ngayon yung magiging design trend natin? Ano yung magiging design trend natin? Between the two. Is greater than or equal to. Okay. Ano yung magiging design strength ng natin? So yung PU natin dito is equivalent to this value. And then yung PU natin dito, ilan yung PU natin dito? This is equal to this value, 5221.15. So ano ngayon yung ating governing design? So that is based on bending stress, tapos i-compare natin yung na-solve natin based on the bearing. So ano yung mas maliit, yun yung kukunin natin na governing design strength natin. Kasi pag kinuha natin yung malaki, hindi nga siya mag-fail. Ano bang mas malaki dito? Mas maliit. Okay. So yung nag-govern dito, yung based on bending stress, 2640. Kasi pag kinuha kasi natin yung mas malaki, which is 5221.15, which is based on bearing pressure, hindi nga siya mag-fail based sa bearing pressure natin, mag-fail naman siya sa ating bending stress. So we have to get yung design strength natin that is equal to 2640.64. Ito yung mag-govern. Para hindi siya mag-fail based on bending, hindi din siya mag-fail based on our support. Yung bearing sa support. Okay? So yung mag-govern is yung mas maliit. So yung answer natin for number 2 is 2640. 2640 point. Yung 2640.64. So yan yung mag-govern sa ating problem for number 2. So you have to solve both. Pag isa lang kasi, pag sinabi kong design, you have to solve both. Tapos compare. So yung sagot, hindi yung 522. I-compare nyo din yung sagot based on the bending. So magkakaroon na kayo ng conclusion that since the value here in bearing pressure is greater than, kayo na mag-explain, yun yung sagot. So, yun lang yung i-babase ninyo during quiz or during activity or during exam. Hindi yung ito, ibabase ninyo tapos kasi ang tinatanong ko lang is yung design strength. So, you have to solve both. Okay? So, okay. Hindi na ako mag-problem ng design of base plate na rectangular since yun yung ipapa-activity ko sa inyo next meeting. So para naman mag-isip kayo ng iba sa ating sample problem. But actually, parehas pa rin yung approach niya and parehas pa rin yung limit state natin. Kayo na lang yung mag-isip on how to solve naman if our yung dinidesign nating base plate is a rectangular one. Okay? So parehas pa rin yung concept. Kasi yung mas madali yung problem 1 natin kasi ang dinidesign natin is square. So parehas yung B, parehas yung B and N. So paano naman pag rectangular, di ba? Okay. So I will leave for your next meetings ngayon. Problem set ko muna bago ko i-present yung sagot para naman mag-isip kayo ng konti sa inyong activity para maiba doon sa ating example. Okay. So, any questions? Example natin for the base plate. Any questions? Wala? So kindly open all your cameras for your attendance. So paki-open lang yung camera natin para ma-screenshot ko yung mga check kung andyan pa rin kayo o open muna. Huwag nyo munang i-close. Mr. Baledang and Mr. Bana, are you there? O huwag nyo munang i-close. Open. O pag hindi po kayo na-screenshot, o okay? So, wala na bang questions?
Mamabalin nga ko ha? Mamabalin nga isend mo dagi solution, dagi pas activity tapno dati pagkuan ni.
Solution for
Ma'am dagi quizzes tas dagi pas activity si tension kada compression.
I think intention and then ano yung isang sinold natin dati? O nabigay ko na actually yung solve natin during our Google Meet. Ang hindi ko lang nabigay is yung compression,
Ma'am dai ma'am.
your quiz, and then your quiz.
Compression.
Okay. Later na yan. Hindi ko pa na-solve.
Sige.
Okay? I-send ko rin sa inyo or diba yung compression, apat na problem yun. Okay, send ko na lang sa inyo pag meron na akong solution. Okay? So, meron pang question? Okay? Wala na? So you can leave now our meet.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you, ma'am. Thank you, ma'am.
Ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Wait,
Thank you, ma'am.